All right, so we're going to review the two transformations that I've already showed you. The first one is dilations. Okay? So dilations is where something grows and shrinks. It's like when you have an eye, when you go to the eye doctor, and they put those drops in your eyes. At first, it looks like that, and then it looks like this. And the reason they do that is so they can look in there, okay? But the shape of the pupil does not change. It goes from a small circle to a big circle. So this one right here is dilated, okay? So that's what a dilation does. It takes a shape, an existing shape, and it makes it either enlarge or reduce. Enlarge, of course, means to get bigger, and reduce, of course, means to get smaller. The rule for dilation is this. You get your x and your y, you get your coordinates, okay? Let's call this one A. And then you process it by multiplying it by the scale factor. So k times x and k times y. And that's going to give you your new shape, or the A prime. Remember, this little mark right there is prime, which means new. Okay? That's the new shape. And that's going to give you your x and your y for that point. Okay, so that's dilation in action right there. If you have a scale factor that is less than 1, it's going to shrink. It's going to get smaller. Okay? If you have a scale factor that's more than 1, it's going to grow. It's going to get bigger. But if your scale factor is 1, it's going to stay the same. It's not going to grow or shrink. It's going to stay exactly the same. It's just going to be a copy of it. Okay? So that's how you use scale factor. But the one thing you do have to remember is that you always multiply. Only. Okay? I know when a reduction happens, you want to subtract, and when an enlargement happens, you want to add, but you don't. You always multiply. Even if your scale factor is a fraction or a decimal, always multiply. Okay? So that's dilations. Then I taught you translations. And when we do translations, I tell you to think of one word and to look at those two letters in there to remind you for the word slide. Okay? And all it does on a translation is slide. That's exactly what it does. So say I have this triangle here and I'm sliding it horizontally. If I'm sliding it horizontally, I'm changing the x. Okay? If I'm going to graph, just like this one right here, and I'm sliding this shape horizontally, let's put it right on the x-axis. All I'm changing is the x values, okay? I'm not changing the y value at all because it's not going up or down. It's just sliding across, okay? So if I go to the left, I'm subtracting from the x. If I go to the right, I'm adding to the x. And I'm just using the letter A for a random number, okay? Now if I'm on the same grid, and this time I got my triangle here, and I'm going up and down, now I'm not changing the x value here because right here the x value is 0, and if I move it up and down right there, it's still 0. It doesn't change at all, okay? All I'm changing is the y value. So if I'm going up, I'm adding to the y, and if I'm going down, I'm subtracting from the y, okay? You have to remember that that's all the motions are. So on these, that's the rule. You get your x and your y coordinate, let's call it A, and you're going to modify the x by either adding or subtracting, and then you're going to modify the y by either adding or subtracting. So that gives you your A prime coordinates. Okay? So that's the rule for translation. You're going to modify the x by adding or subtracting, and you're going to modify the y by adding or subtracting as well. But that's all you have to remember is this right here. This is the most important thing. If we're subtracting, we move to the left. If we're adding to the x, we're moving to the right. If we're adding to the y, we're going up. And if we're subtracting from the y, we're coming down. Okay? All right, so those are the two that we already covered. Okay, and yesterday you showed me that you knew how to do this part at least. This translation and dilation is pretty easy. It's just multiplication. So the one we're going to learn today is called reflections. You should be writing this down. Okay? Write it down. If you need to stand up in your chair again so you can see the board, do it. All right, so reflections is exactly what it sounds like it is. It's reflections. When you think of the word reflections, you think of a mirror, okay? So I'm not going to put a mirror here because we're not dealing with that, but I'm going to put a coordinate grid. All right, so here is my coordinate grid. Let me try to center it as much as I can. Yeah, that's close enough. All right. Huh? That's it. All right, so we have our coordinate grid and we're going to put something on it, okay? So what did I put on it?
A face.
I put a face, okay? Which way is he looking? Left or right? Look at your screen.
Right.
Okay, well, no, he's not. He's looking to the left, okay? So he's looking to the left, okay? So let's pretend that this line right here, this y-axis, let's pretend that that's a mirror, and he is sitting right there, okay? So this right here, between my pinky and my pointer finger, is the distance of his nose to the mirror, okay? So if he's looking at himself, is the person in the mirror going to be like that? No, right? That doesn't make sense. When you look at a mirror, you don't see the back of your head. Is it going to be like this? Obviously not. You don't see the top of your head when you're looking at the mirror. Would he be like this?
Tampoco.
No, that doesn't make any sense, okay? Now would he be like this?
Yes.
Okay, more or less, right? He would be like that, but this distance right here, is it going to be shorter on the mirror? Or is it going to be longer in the mirror? Or is it going to be the same? It's got to be the same, okay? So whatever this distance, and that's why I put the little smiley face on his nose, okay? So here he is 1, 2, 3, 4, 5 squares away from the mirror. So this guy, which is the same guy, has to be the same. So 1, 2, 3, 4, and 5. So the little smiley face is right on the axis, and so is this one, okay? So that is how reflection works. Okay, so wherever we reflect, this one is reflecting over the y-axis. So if it's over the y-axis, all it does is flip over. It flips over and it has to be the same exact distance. Okay? Alright, now let's take him and go this way. So if I was going to reflect him this way, and he was going to reflect over the x-axis, where is he going to end up? In quadrant 1, 2, 3, or 4. If he's reflecting over the x-axis, well, obviously, if he's going over the x, he's going to land right here, okay? And again, same thing. We're not going to be facing the opposite way. We're not going to be facing the wrong way. We're going to be facing right at each other. And we need to match the distance between the mirrors. So let's say this is the mirror right here this time, the y-axis. If I'm reflecting, I'm 4 squares away. So I need to go 4 squares away and put his nose right there. And that would be a reflection over the x-axis. Okay? Really, you paying attention? Come on, really, you gotta pay attention. Alright, so let's write down the rule for reflection. So everybody write this down. Alright, so again, this is reflection. And this one, you can remember the same thing, just like the translation. We have the F and the L for flip, because that's what we're doing. On these faces, first he's facing down, now he's facing up. So we flip them over, okay? Just like on a reflection, when you look at yourself in the mirror, or when you have like some letters on your shirt, in the mirror they're backwards, right? Okay, the rule for this, we're only going to learn 2 rules. We're going to go over the x-axis, which is this line, the horizontal line, and we're going to go over the y-axis, which is the vertical one, okay? If we're going over the x-axis right here, on this one, we're going this way. The only thing that's going to be changing is your y value, okay? So the rule is this, x, negative y, okay? And the negative doesn't necessarily mean we're going to change the y to a negative, it just means we're going to change its sign, that's it. If we're going over the y-axis, so we're going from this one to this one, the only thing that's going to change is your x-axis. So the rule for this one is negative x, y. So again, these right here and this one right there, they don't mean that it's a negative number, okay? All it means is we're changing signs. So if it's a negative, now it's a positive. Whoops. If it's a positive, now it's a negative, okay? So we're going to change the sign, and that's it. Okay? All right, now let's try some. All right, so we have our two faces here. Remember, the rules are right here. So we have our x. If we go over the x, we are changing the y value. If we're going over the y, we're changing the x value. Just remember, it's the opposite of what it says. The x, you change the y, you change the x. Okay? So let's do this guy right here. So if we look at the blue guy right here, we have to find the coordinates of his nose. The coordinates of his nose right now, or the little circle on his nose, are going to be 1, 2, 3, 4, 5, 6. So positive 6. And 1, 2, 3, 4, positive 4. Okay? Right here, we're going over the x. So again, if we're going over the x-axis, we need to change the y. That's the rule. Over the x-axis, you change the sign of the y. So the x is going to stay the same. And the y, it used to be a positive, now it's going to be a negative. So it's going to be 6 and negative 4. So that's exactly where we need to put this second face. We need to put his nose at 6 and negative 4. So again, I need to go over 6. 1, 2, 3, 4, 5, and 6. And this time I need to go down 4. 1, 2, 3, and 4. Let's put him down. And there he is. Let's angle him the way he should. There. So now this is a reflection of the blue face to the red face. Okay, remember, all we changed was the y value. The x value, which is this line right here, stayed the same. It's still at 6. Except now it went from positive 4 to negative 4. So only the y changed values. Okay? Alright, now let's show that real quick. So again, x stayed the same, y was a positive, changed into a negative when we went over the x-axis. So now let's do over the y-axis. Okay, so for the y-axis, let's face them at the x-axis, like this, at the y-axis rather. So let's put them closer. All right, so his face is right there, his nose is right there, so let's get the coordinates for his nose. He's going 2 and 1, 2, 3, 4, 5, and 6. So his coordinate for his nose is at 2 and 6. Okay, so this time we're going over the y-axis. Okay, so he's at 2 and 6. So this time the rule for going over the y-axis is we're going to change the value of the x. We're going to change the sign of the x, and the y stays the same. So it is a positive 2, so now it's going to be a negative 2. And the 6 stays the same. So now we're at 2 and positive 6. Or negative 2 and positive 6. So now let's get our face. So we're going to go negative 2, which is over to the left 2, and then up 6. 1, 2, 3, 4, 5, and 6. So let's grab the other nose. Back where he was. And there you go. So that, again, you can prove it right by just counting how far he is from the mirror. Right here, his nose is 2 blocks away from the mirror, and so is this guy right there. So that's the reflection over the y-axis. So again, over the y-axis, you change the x. So it goes from positive 2 to negative 2. 6 stays the same. When we flipped over the x-axis earlier, we kept the x the same, and we changed the y value from negative to positive. Okay? All right, so that's rotation. That's dilation, reflection, and translation. Remember, the reflection is the new one.